where you're trying to scale every year and you're kind of dealing with a lot of newer customers and you're getting much more customers than that is kind of anticipated. So to just start with, I am Sham. I am responsible for site reliability, web performance, and all the operations associated with security in my company called Now. And so what we do at a very high level, without getting into the company, is we are a B2B sales transfer platform used by enterprises. We have close to 175 customers in the US, and we have close to 43 Fortune 1000 companies as our customers. We don't have any free plan or such. We have all our customers who are paying, and we just charge them the dollar. So we are a true product company, and we have experienced 100% YOY growth for the last 4 to 5 years, and we are growing much more than we kind of anticipated. And we develop everything from India. We are mostly into Rails, and we are completely a Nginx shop, and we have good folks in our house who actually do this. Right. So I'm going to start with a problem statement of what I'm going to talk in this topic. It's more around how do we scale existing web applications to handle more volume. So as a SaaS business, right? So one of the things which you do from a business standpoint is how do you reduce the cost to serve your customer? Like what is your sort of how do you get more value for your existing stuff, right? I mean, sure you could build, get more servers, build more features. So sort of how do you use your existing talent pool to deliver more value, which will bring you more money rather than sort of investing more on making sure you can handle the existing customers, right? So there are lots of strategies available. You could actually sort of re-architect stuff. You could use software stack like Go or Rust, which compiles to the bare metal and gives you efficient level performance. But what I'm going to talk here is I'm going to talk about a specific strategy which can be applied for specific use cases, which has worked out well for us, right? So I'm going to start with a very brief introduction on what Nginx is. It is called Nginx. It's pronounced as Nginx. It was created in Russia by a guy called Igor, a very smart guy. And it is a high-performance web server, reverse proxy, SSL, TLS load balancer, and all of these things, right? So basically, you have Apache, you have IIS, you have Tomcat, and all of these things, right? So these are what you call as web servers and app servers, and liquidity and stuff like that. So Nginx is one of that bunch. So one of the biggest feature of Nginx is it is highly concurrent and it has a very low and predictable footprint, and it is built to address the C10K challenge. So I'm going to talk about what C10K challenge is. It was a terminology which came around the end of 90s or start of 2000. What the challenge is, sort of how do you handle 10,000 concurrent connections, right? And what is the strategy you use? If you take a server like Apache, right, today, they use a technique called pre-forking, where each connection is sort of handled by a processor in a right? And when you get more and more connections, that is going to be a lot more resource consuming and a lot more slow. So if you have used Apache at scale, you will probably feel my anger. So that's one. So I'm going to talk about how Apache and Nginx differ. So a typical non-working server different, right? So take a typical app server. You can take Tomcat or IIS or your Apache or Puma or any sort of app server which your apps use, right? They use listen socket and they are blocking. They form a what you call as a blocking IO. They wait for an event like someone sends a request. They accept the connection, they call it and they assign it to a socket, and they probably spawn a thread, and that request works till the end of that thread sort of handles until the end of the request, where it requests for resources, it reads, it does the processing, and every thread spawned by that socket actually kind of handles till the life cycle, right? So that's what it does. So at any point of time, a worker might spawn multiple threads, and each thread can possibly handle only one active connection at a time. The difference in Nginx is it uses a kernel feature called events, right? What it does is it has a lot of listening sockets and connection sockets, and it uses the kernel feature. It has what you call a sort of highly efficient run loop, where each request is assigned to the run loop and it smartly spins it out. So every request is kind of asynchronous and non-blocking. That is the difference between a traditional app server and Nginx. Nginx is non-blocking, all the other servers are blocking. So that's what it makes it very efficient. That's how Nginx is better in most of the app servers. So I'll also talk about Lua. It is a language which came out from a college in Brazil in '93. Why it was invented was at those times, United States had some sort of export restrictions to South America, and these people had no way to get any modern language or any such. So they had to sort of invent their own language, and that's how Lua was born. One of the biggest features of Lua is cross-platform. Right from Windows, Linux. Windows, Linux is just like the very easier subset. I'm talking about HP, Solaris, Unix, PS3, mainframes. They pretty much Lua runs on almost all the platforms. Be it the different CPU architectures, the different CPU, on different OS, and all of those things. Right? They run everywhere. It is dynamically typed. It is very lightweight, and it is embeddable. When I say embeddable, it is a language which you can use it for your bigger project. Something like you can use it as a language for your codes, right? So when I say it is used in many industrial application, it is more like your Adobe, your games, any of your games like World of Warcraft, a lot of game engines, your Angry Birds, all of them internally for the sake of scripting capabilities, they use Lua. So Lua is generally fast, and they have a Lua JIT, which is a state-of-art Argentine compiler for Lua. It is written in C and some assembly, and it is lightning fast. It actually generates assembly for you to be actually very lightning fast. Though it's a scripting language, it is way faster than your typical language like Python or Ruby or whatnot. Right? It is very fast. It matches C reliable speeds depending upon the script you have written and the way you have written. I'm going to talk about a platform called Openresty. It was created in China by Fusion Zhang of Taobao. Taobao is nothing but the eBay, Amazon of China. So whatever sites we have around the world, like eBay or Uber or everything, these Chinese guys have their own version. They call it fancy names, AliExpress, Alibaba, everything, right? So they created Alibaba, and when I said Taobao is like Amazon, it is a site where the whole of the world purchases in wholesale from Taobao, right? So you have Alibaba or the AliExpress where you can buy stuff at wholesale at dirt cheap prices. They internally use Openresty. So it is a collection, it's basically a platform which integrates the Nginx, Lua JIT, and a lot of high quality Nginx modules like Postgres, MySQL, Redis, and whatnot, right? So Nginx Lua is a static C module which is close to around 500 lines of C code. What it does is it allows you to run Lua code, base Lua code as a part of Nginx itself. It's like your common gateway interface capability without for Nginx, but where it allows you to run Lua code. The bigger advantage of this is since this is a part of Nginx, it inherits a feature of Nginx which is sort of asynchronous and event driven. Your Lua code can be synchronous, but your actual code is sort of asynchronous. That is sort of executed asynchronous. That's the bigger advantage. It's used by Alibaba, Cloudflare, Basecamp, Paytm. Many of the high traffic sites in the world right now today use Openresty. So I'm going to come up with a little code. This is not a benchmarking exercise per se. I mean, there is not a lot of scientific thing to it, but it's just to show how the performance of Openresty differs from your traditional web app framework, right? So today, most of us write web applications in .NET, PHP, Ruby, Python, and Java, right? So you typically end up using a framework to gain productivity, and you typically use those frameworks so that your business ready for your customers, and as well as you are also able to sort of attract the right talent to your company to actually join your group, right? So I'm going to take an example of Rails and Cuba. This is a very basic example. People who are familiar with Rails, know this is nothing. I mean, it's nothing great about this, but this is a very simple controller which displays a sentence, sentence called "Hello World" once you hit the URL. This is the same code in Cuba when it is a part of your Nginx configuration, right? So what I did was, after I wrote this code, I ran Apache Bench, right? Apache Bench is a stress test tool which you can run against a certain endpoint with a certain where you can simulate a certain load, where you can issue GET requests or HEAD requests or whatnot, and you can also certain assert a certain concurrency. So I'm not sure if it is visible completely. So this is Huma and Rails. Huma is one of the app servers in the Rails world. It is threaded. It's a sort of highly performance server, and I have issued up to 1,000 requests with a concurrency level of 25. The time taken to complete the Apache Bench stress test was around 3.6 seconds, right? And it gave the percentage of the maximum time taken, right? And the same on Openresty took around 0.36 seconds. Okay. But if you look at it, we are looking at a 100x difference in a simple hello world case, right? But this is a simpler example. Let's go to a different example where I tried to look up a cache item, right? So this controller method, what it does is it looks up the cache like Redis or Memcache or whatever. It looks up an item for an item, and it enters it to the as the output to the browser. The same in Hua looks somewhat a little more verbose, but because there are some levels of error handlings and stuff like that. But this is how it is in Hua. And the same when I ran an A/B test for 1,000 requests with 25 concurrent with a concurrency level of 25, I was able to complete this in around 8 seconds, and the same took 0.148 seconds in Google, right? Now, the bigger thing to note here is we are looking at a massive performance increase. I cannot quantify like you can get a guaranteed this much 10x, 100x, 55x difference. Your mileage may vary depending upon your app. So it's just not the app, right? I come from you have to look at from all the aspects of infrastructure also. Your network conditions, what sort of how your app is architected, what sort of internal services it has to look up, and a lot of things are at play. It wholly depends upon your app architecture and your infra architecture to get a result, right? So one of the bigger things you have to note down here is Kuma or any other web application framework like your PHP, Ruby or .NET will have a sort of blocking IO. Your app server has to wait to serve the request before it can take up the next request, right? But Ruba, since it's a part of Nginx, it is able to serve it immediately because it benefits within a non-blocking window. So one of the ways people could argue is, can't I have a bigger or a better worker pool on my app server to handle this kind of load? Yeah, you can, but the cost will be enormous because you'll have to provision more resources, and you will still end up eventually running out of these workers at scale, right? So just to add, this is not a scientific or a stats kind of thing, but it's more based on our experiences. Your mileage may be depending on. So use cases for Openresty is right. So I told that Openresty is sort of highly performant, but can I write my entire application on that? You can, you technically can, but doesn't mean you have to. What you are looking at is you could look at sort of highly cacheable operations, right? So take a typical example, right? Click info, right? People look at the scores. I mean, the site gets updated every 30 seconds to display the data scores. Right? Their typical architecture, I don't know about their architecture, but a typical case like that is you're talking about 100% reads or 99 or 10 nines of reads, and where the people have some architecture where they publish the scores once and it's mostly reads all the time, right? So any sort of highly cacheable operations which you can serve from RAM or something like that is the best case for Openresty, right? And let's say you have some business context aware request routine. Let's say you need to do, let out a feature, you need to do a sort of A and B testing kind of thing. You could have circuit breakers or feature toggles within your application, but you could also have some context level routing where, being a full-fledged web platform, it can also look at your query strings, your headers, your cookies, and it could do a lot more things, and it could make a decision on whether to route it to this version of the app or that version of the app, something like that, right? And let's say you have some backend APIs or sort of hidden APIs, or let's say you have some legacy APIs, and let's say you don't want to touch it, but want to add some features like Ajax or WebSockets or something like that. You want to expose some kind of functionality, you could do that. This is all at the application layer. At the infrastructure layer, you could deal with a lot of abuse protection, like people who repeatedly scrap, people who do some sort of stuff like DDoS attacks or something like that. You could do that. Cloudflare is a DDoS company. They use Openresty exclusively to sort of handle these things, right? And same way, business context level for balancing, whether you want to ascertain, give more priority to your paying customers versus your free customers and stuff like that. And other is around the enhanced logging, where you could request, you could look at the headers and do some extended logging around what is coming around for your people to, analyze this stuff. So basically, these are some of the use cases which are there right now in production used by various high traffic companies. Sure, you could use for other specific cases. So, why does it matter to us is to give a peek about our architecture. We are an API-driven single-tenant SOA platform. Due to security and regulatory reasons, we cannot be multi-tenant to our customers. We have to be single-tenant for all our customers. To put things in perspective, we have close to 2,000 instances of application running in production right now, and we are very integration heavy. And when you are talking about enterprises, they would use Salesforce, a lot of Microsoft software. They would have their own CRM integrations. Those things. We are very integration heavy, right? We deal with a lot of we deal with several million transactions, and we have found that very highly cacheable operations are better scaled out using Openresty rather than using Rails. So I mean, we use a Rails stack. It is faster and cheaper, right? So this is how we use. Before we use Openresty, we have an API gateway since we are sort of integration heavy, and it hits the backend service. And if it's a cache operation, it looks up cache and gives back. It is still faster than hitting the DB each time. But after using Openresty, what we did was Openresty actually hit the cache directly, and if it was not present, we actually looked up the service, right? Now, in my tests where I showed about cache lookup, Openresty was at least 100 times more faster than us than this in our test, right? And it has actually helped us scale a lot more. Being enterprises, we have companies which are smaller and we have companies which are whales who have large sales teams. Sales teams like 1,000 people sales team or 5,000 people sales team, and they hit our platform consistently, right? So this helps us scale in a much more cost efficient way, in a faster way, rather than have to provision more servers and then incurring more cost, but with a simpler change. So this is one of the use cases of how we use Openresty.
Yeah, question. What do you store in Redis cache? Is it API response or
API response?
Okay. Then you can just do simple HTTP caching, right? Why do you need Openresty for that or Redis cache for that?
Valid point. This changes not often. This has a lot of business. I have simplified the actual architecture, but there is a lot of much more moving parts that it is not necessarily cached.
So kind of remove your business logic even if you Openresty or the part of business logic to Openresty?
Business logic still remains there, but the API response alone is moved to Redis, and this looks up the Redis cache before looking up the SSL servers.
Probably you have done that.
I don't know architecture, but so in summary, right, we feel that Nginx is cemented architecture and feature-rich expressive language and its performance is a powerful combination. What you have to notice, this is not a, there are web frameworks based out of Openresty. It's not something what you would want to do, what you would want to write your complete platform or a complete project at. There are specific use cases where it could be a valuable add-on, right? As I said about the use case, right? It has a gentle learning curve. I mean, if you're familiar with a specific scripting language like Python or Ruby, you could get started with it much easily.
How is the library ecosystem now? You have a lot of libraries.
Yes, we do. There is this awesome listing. There is a link which has all the libraries. You could connect to all the database management system, all the caching mechanisms. It has a web framework. It has some web frameworks. It has CSS preprocessors. It is good.
But I think Apache also supports non-blocking also.
Yes, but it is not as the same.
Compiler thing, right?
It's not the same as Nginx.
Like there is a proposal to add multi-threading in Nginx.
Yeah. Yeah.
So I wonder why would they do that?
There's the argument. There's a recent article that came out week back.
Yeah.
So it's an interesting case.
So people always want the one thing they don't have. Right. So that's how it is. So this C10K problem link is especially interesting. It gives a history of why C10K problem was relevant and what Nginx did at that time to sort of address it. Apache latest version 2.4 point something actually addresses a lot of these shortcomings and is more stable. But yeah, Nginx has its own ecosystem now. And yeah, I mean, the bigger thing is they were the first to move this, right? I mean, you have an adoption at an enterprise at a bigger size, right? Your top users of Openresty include a lot of these site traffic sites in P2C space, right? So they have the first mover advantage, but
Not Openresty, Nginx itself